Welcome all my dear student. This class I am going to discuss with you cyanide poisoning with their official example. So in the previous session I already discussed with you what are antidote and what are all the official example to be used for the treatment of cyanide poisoning. Here in this session I am going to discuss with you specifically what is the inorganic substance like sodium nitrite and sodium thiosulphate to be used for the treatment of cyanide poisoning. Let's see one by one. Here sodium nitrite, formula for sodium nitrite NaNO2. It contains not less than 97% and not more than 101.0% of sodium nitrite, calculated with reference to the substance dried over silica gel for 4 hours. So next we'll see the how do they prepare sodium nitrite. The preparation, this is manufactured by many methods. However, the most suitable method involves the absorbing of nitrogen oxide gas obtained during the catalytic oxidation of ammonia and oxygen by sodium carbonate solution. The solution is concentrated to crystallize out the product. So let's see one, that sodium carbonate when treated with nitrogen oxide gas on catalytic oxidation of ammonia and oxygen. Here the catalytic oxidation with catalytic oxidation of ammonia and oxygen. Here there is a conversion of sodium nitrite and removal of carbon dioxide. So what is the preparation of sodium nitrite? When sodium carbonate treated with nitrous oxide and catalytic oxidation of in presence of ammonia and oxygen, there is the form of sodium nitrite and removal of carbon dioxide. The other methods involve the reduction of sodium nitrate to nitrate by lead in iron pan at around 450 degrees Celsius or by the action of quicklime followed by sulfur dioxide, wherein calcium sulphate precipitate is formed. So it is to be filtered out and filtrate allowed to crystallize out sodium nitrate. So the other method, reduction of sodium nitrate by lead in iron pan. That means, so for what is the formula for sodium nitrite to be prepared from sodium, reduction of sodium NaNO3 with iron, lead in iron pan at around what is the 450 degrees Celsius or by the action of calcium oxide. What is the formula for quicklime? Calcium oxide by sulfur dioxide, wherein calcium sulphate precipitate is formed. So there are three methods of preparations overall sodium nitrate. So first one, on treatment with nitrous oxide and by catalytic oxidation of ammonia and oxygen, thereby sodium carbonate with nitrous oxide and oxygen with ammonia catalytic reduction, there is a formation of sodium nitrate. And another method, sodium nitrate to be reduced to sodium nitrite in presence of lead in iron at 450 degrees Celsius. And another method, and quicklime followed by sulfur dioxide. That means calcium oxide with sulfur dioxide, wherein calcium sulphate precipitate is formed and is to be filtered up and crystallized out sodium nitrite. So the crystallization is carried from hot water. So this is a method of preparation of overall sodium nitrite. So next we'll see the properties. So it occurs in the form of colorless to slightly yellow crystals. What is that? Colorless to slightly yellow crystals, and the crystals are a white or slightly yellow granular powder. It is odorless, taste is saline, and it is deliquescent. Okay, next it is water soluble, and solubility, if you see the solubility, it is soluble, sparingly soluble in alcohol. When exposed to the atmosphere, it deliquesces and slowly gets oxidized to sodium nitrate. Its aqueous solution is alkaline. It is easily decomposed by the acidification with dilute sulfuric acid. It is a reducing agent and it is oxidized to nitrate in an acidic medium. So slowly one by one we'll see the property. It is a colorless, odorless, and solubility soluble in water and sparingly soluble in alcohol, and it is easily exposed to atmosphere, so that the sodium nitrate to nitrate NaNO2 NaNO3 in aqueous solution, it is alkaline. It is easily decomposed by the acidification with, that means easily decomposition with the acidification with sulfuric acid. There is a salt of sodium salt. Okay, next when it is treated with potassium chlorate and nitrous acid, so it is converted to nitric and removal of potassium chlorate. So majorly sodium nitrite act as an oxidizing agent. Now nitrous acid when treated with potassium iodide and sulfuric acid, so iodine liberated and nitrous oxide, iodine liberated and nitrogen oxide, removal of nitrogen oxide, and water and potassium sulphate. So identification, it gives reaction which are characteristic of sodium and nitrite. Okay, so next, test for purity. So it is tested for heavy metal. We know already how to perform the heavy metals like lead, limit test for lead, and limit test for chloride and sulphate, and loss on drying. Okay, next, how do you perform the assay? So the method is based upon the oxidation of nitrite to nitrate. Why? Because we are preparing and from nitrate to nitrate, and this method is mainly based upon the oxidation of nitrite to nitrate. So 1 gram of the sample is weighed accurately and it is dissolved in water to make 100 ml. First 1 gram of the sample to be accurately weighed and dissolved in 100 ml of water. So pipette out 10 ml of this solution is slowly added, and 10 ml to 50 ml of 0.1 N potassium KMNO4 solution. The 100 ml of water and 5 ml of sulfuric acid in contact with acid, nitrous acid is formed, which immediately gets oxidized to nitric acid by potassium permanganate. So as nitrous acid is volatile, while adding the solution of sodium nitrate, a tip of the pipette must be kept below the level of the solution. Then the known excess of standard 25 ml of oxalic acid is added. So the mixture is heated to 80 degrees Celsius and the oxalic acid, that means excess, is back titrated with the standard potassium permanganate solution. So overall, how do you perform the assay? First we have to, this mainly depends upon the oxidation of nitrate to nitrate, nitrate to nitrate. Then sodium nitrite when on acidification, so sodium bisulfate and removal of nitrous oxide. That nitrous acid on oxidation, it is converted to nitric acid. So the each ml of 0.1 N potassium permanganate is equivalent to 0.00345 gram of sodium nitrite. Then storage, it is prepared in tightly closed container. So next we'll see the action and uses. We are studied under the treatment of cyanide poisoning. Here and among other than cyanide poisoning, pharmacologically nitrite ions act by relaxation of smooth muscle and are having vasodilation action of coronary blood vessel. Due to this action, it is regarded to be effective in angina pectoris. What is that? So, due to this action, it is regarded to be effective in angina pectoris. However, inorganic nitrites slow onset of action. That means it takes time for the starting of actions, that onset of action. The organic nitrites like ethyl nitrite, amyl nitrate and glyceryl nitrate are having better onset of action and hence are used clinical when compared to sodium nitrite. Some other organic nitrites like ethyl nitrite and amyl nitrate and glyceryl trinitrate are having better onset of action than nothing but. So the start of action is very rapid when compared to sodium nitrite, and hence these are used clinically. Nitrites easily form methemoglobin, which in turn react with cyanide ion. So this is that sodium nitrate comes under the physiological mechanism of action. That means, so first the hemoglobin already present in the blood, that it converts after taking of sodium nitrate, it is converted to be methemoglobin. So cyanide to non-toxic cyanide, there is a formation of cyanide to bind with the non-toxic cyanide, so it can be easily removed from the stomach unwanted footstep or unwanted poison and form cyanomethemoglobin. So because of this mechanism, sodium nitrate is used in cyanide poisoning. Sodium nitrate is also used as a food preservative. It is only antioxidant application of sodium nitrate is in the prevention of rusting of surgical instrument by immersing them in dilute solution. So overall usage of sodium nitrate, first one cyanide poisoning and also used for the treatment of angina pectoris and in order to prevent the rusting of surgical solution. The solution to be sodium nitrate solution to be that surgical device to be immersed in sodium nitrate solution in order to prevent the rusting of the surgical instrument. And another one is it is to be used for the cyanide poisoning. So and also act as a relaxation of smooth muscles. So these are the major uses and actions of sodium nitrite. Now let's see sodium thiosulphate. So what is the molecular formula for sodium thiosulphate? This is also one of the use for the treatment of cyanide poisoning. So what is the molecular formula for sodium thiosulphate? Na2S2O3, 5 molecules of water. And what is the molecular formula? 248.2. And you know what is the percentage purity, that means not less than 99% and not more than 101% sodium thiosulphate. It is also known as sodium hyposulphate or antichlor or hypo. What is the other synonym? Sodium hyposulphate, antichlor or hypo. So it is to be preparation, the preparation to be, it is obtained from soda ash, sulfur dioxide and sulfur. First of all, soda ash is dissolved in hot water. Through this solution, sulfur dioxide is passed. So the resulting solution of bisulfate liquor is treated with further quantity of soda ash, which is then made to heat with the sulfur. Next, the solution is then concentrated and allowed to settle and it is crystal. So first, that soda ash is nothing but sodium carbonate. When it is treated with sulfur dioxide, so there is the formation of sodium bisulfate. Then removal of carbon dioxide. Then this sodium biosulfate again treated with soda ash. So sodium sulfate is formed. Then this sodium sulfate is treated with sulfur. There is a formation of sodium thiosulphate. There are the three methods involved in this method of preparation of first soda ash treated with sulfur dioxide. So sodium bisulfate is formed. This bisulfate treated again with the soda ash. So sodium sulfate is formed. So this sodium sulfate on treated with sulfur, the formation of sodium thiosulphate. Next we'll see about the property. So it is found in the form of large colorless crystal, coarse crystalline powder as an transparent monoclinic prismatic crystal, odorless, and having alkaline taste. So both sodium nitrite and sodium thiosulphate become alkaline taste and colorless, odorless, and it melts at 50 degrees Celsius while decomposes on being heated to 100 degrees Celsius. So it fluorescence in dry air and deliquescence in moist air. So deliquescence is nothing but, so it leaves watery liquid while we store on moist air. Then so it is soluble in water 0.5 pound but insoluble in alcohol. On boiling, so aqueous solution decomposes due to its reduction to sulfide and oxidation to sulfate. So reduction in sulfide and oxidation to sulfate. So next we'll see that sodium thiosulphate on heating. So sodium sulphate and sodium sulfide. So it's having on reducing actions on halogen. That means halogen means chloride, bromine, iodine. So these are comes under halogen. So when it is treated, sodium thiosulphate treated with halogen, sodium iodide and sodium tetrathionate, Na2S4O6, sodium tetrathionate in aqueous solution decomposes slowly in cold but rapidly on heating. So sodium thiosulphate to sodium sulphate and remove sodium sulfide. This sodium sulfide to but rapidly on and sodium sulfide to sodium sulfide and removal of 4S. So next we'll see that its alkaline solutions are stable. For strong, the sodium thiosulphate solution, a sufficient amount, that means 0.1 to 0.2 gram per liter of sodium carbonate or borax is added. When acidic such as hydrochloric acid is added to sodium thiosulphate, it decomposes and liberating sulfur dioxide and water. So on treated with hydrochloric acid, then thereby it liberates the sulfur and water and sulfur dioxide. So it is able to reduce ferric salts to their corresponding ferrous. So it's having one more capability. That's having capability to reduce the ferric to ferrous form when it treated with ferric salt FeCl3 on treatment with sodium thiosulphate is converted to FeCl to ferrous salt. That means Fe plus 3 plus or ferric to Fe2 plus ferrous and removal of sodium chloride and sodium tetrathionate. So next, this ferric chloride when treated with sodium thiocyanate and water, then there is ferrous form, sodium chloride and sulfuric acid and sulfur. So next, what are the identification? It gives the characteristic of sodium and thiosulphate. So test for purity, it is to be tested as a reaction of arsenic, calcium and heavy metals. Next we'll see the as we already known about how to perform the limit test for arsenic, chloride, sulfate, lead and iron, etc. So next we'll go for the assay. So this an accurately weighed quantity, that means 1 gram is dissolved in 20 ml of water and titrated with 0.1 N iodine using starch solution as an indicator. So the sodium thiosulphate, so to be treated with iodine using starch solution as an indicator. So uses, it is most important use as antidote in treatment of cyanide poisoning. So as like sodium nitrate, here the sodium thiocyanate also to be used for the both sodium cyanide, sodium thiocyanate and sodium nitrate used for the cyanide poisoning. In fact, it is given in IV intravenously, which is immediately followed by the injection of sodium nitrite. Cyanides are highly poisonous and the poisoning has been instantaneous and fatal. So the sodium thiosulphate inactivate cyanide by forming thiocyanate. It also acts as an effective antidote in poisoning, which gets resulted from iodine preparation. So sodium thiosulphate was considered useful in parasitic skin disease and ringworm and in controlling athlete foods, etc. So however, nowadays it is not used clinically for skin disorder due to better available drugs. When used in large doses, it causes cathartic action. So it is used extensively in photographic industry as hypo. So overall uses, so it is mainly used for the treatment of cyanide poisoning and also control the athlete food, and clinically it is for skin disorder. And also to be used as a cathartic action certain. Okay, and what is the, let's see what is this dose level. 0.3 to 1 gram by IV means intravenous and IM means intramuscular injection. So what are all the formulation to be available? Sodium thiosulphate injection form are available. So these are the two most important drugs to be used for the treatment of cyanide poisoning, like sodium nitrite and sodium thiosulphate. Thank you.